welcome back. This video we start to do this number 10, which is the last project for this book, Mastering OpenSCAD within 10 projects. This book was written by Jochen Kurdos. It's a very interesting 10 projects. And we have this last project talking about the fan wheel. From this picture, you can see the middle is kind of simple, just a cylinder. But the tricky thing is how we can make some adjustment about the angle to make these blades. And if we can make one, that will be easy. We just duplicate that to our circle. So that is the basic things. And again, in the GitHub, if you come to the site, I have this folder, Master OpenSCAD, and already the first 9 projects here. And also, these are the mind map file. And I have already kept tracking from the project 1 to this project. Every project you can read from the book, but I have put in the key knowledge point for this project talking about listed here. So this mind map, I hope, can be your quick reference. I will not talking about this 11. That is just some functions or features that are not covered in this first 10 practical project. You can read afterwards. So let me close this, and we start. And we save to the number 10. If you like my video, please subscribe. I'm more than welcome to get your suggestions and comments. So let's go. So first, we quickly do our module. Our module called fan wheel. As usual, we make a blank. Then we will call fan wheel. Also blank. Control S. So ensure you have a type correct, so there's no error. Then we can start to make our perimeter. So we have outer radius. So those perimeters, outer radius, this big one is give our default value. Inner radius, okay, 15. Blade count. So this can be the parameterized. So we're starting from 8. Outer width. One outer, one inner. And we have a thickness. Thickness. We can also check thicker. This twist is our new perimeter we will use in the line extrude. So we put that is minus 30, that's the degree. Angle of attack, 45. This we need to understand what that means. And then our module have a sub-module blade, which we will use that to build our blade. And we put a blade as our debug. Okay, that's the first one. We have done this without arrow. So that's the base. Now let's save that to the second. We're starting to build the blade. And here you can read some mathematical discussion. So it's kind of our part of the circle, and we made this outer the radius minus the inner radius, then you have this part of the ring. But how to calculate this? That we will use this blade to make the definition. So blade, we don't have our perimeter for now. It's just some the one by one we can do. So first, let's from the bottom we made our square. Square is the 2 dimensions, outer width. Outer width is this, and the inner width this, and we made our the square and start to transform that with thickness, center is true. So we got this one. And we're starting to make this extrude. And when we do this extrude, we will make a twist. So that let's do the linear extrude. So extrude height is blade height. So now you can see here, but we have one arrow. Ignore unknown blade height. Blade height. We don't have this blade height yet, so it's here. So we will define this blade height is equal to outer radius. You see here, this is our blade height. So use this radius, delete the inner radius. Deduct inner radius. Now we will have no arrow, so that is our, because if you don't have that definition by default, they will draw something, but up to the 100. So that's the OpenSCAD is the default behavior. And we have this twist. Let's feel the effect of this twist. So this twist. So just pay attention to here. Let's save. So you see, twist is the twist to the minus 30. So if we say twist the minus 90. So from this angle and twist means they will make this angle, and final is go to the minus 90, so 90 degrees. So if we see we want to 45 degrees, they will into this half. So what we want is we just want 30 degrees. So that is not so big, but is the kind of those blade for the fan wheel used. And we have the slice. The blade twist is the new parameters we are putting here. Slice, we have 10 slice. Slice is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I say I just want 5, see here, just you can feel these lines. They make that 10. But if you want this, I say 10 is not so smooth, you make 100. But just pay attention for 100. It will be time consuming for if your computer is not so powerful. And then we have this convexity. We put 10 as well. Convexity. So if I put that, is kind of the let's see, linear extrude convexity. Trace the scale, convexity. Try setting the convexity parameter default is not true, failed, but 10 is the good value for try. For the down, just by default we use 10. Oh, yeah, here, convexity. If the extruding failed today, try set that, explain further down. And integer convexity parameter specify maximum number of front sides or back sides are ray interaction of object might penetrate. So here, this image shows a 2D shape with a convexity of 2. So that is 1, 2. So these are the concept for if you learn from the graphs theory. You may see this how it will make your 3D shape from the 2D shape being cut by one line. So you can just keep on this 10 as the default value, so we don't change that. So until now, let's continue. We have our linear, the extrude, with adding this twist. Now we rotate that to the from this horizontal, vertical to horizontal. So rotate minus 99 at 0, 0. It should come to lay down, so like here. And then we translate 0 inner height, 0, because we will in the mid center. We will hide that cylinder. We will translate that to outside a little bit based on the inner height. Inner height. Inner height. Let's see which are issue. We don't have. Oh, I haven't defined this inner height. So let's do that. I tried to do this from bottom back to top, is just try to show you step by step what the actual the model looks like in the OpenSCAD. But if you want to practice this, you can just copy this from top line by line. Then you also can get this result. So what I got, I just write down that in the same line. So it's a cosine the something times inner radius. So what's inside this function is anti-sign inner width divided by 2 times the inner radius. Yeah, so it's a shift here. So that is good. We have the single the blade already done. Then we will continue next video to make this tapered shape for the fan blade using the Boolean different operation. See you then.